Hello everyone and welcome to today's session. For those that don't know me, I'm Avit Prasad, GM at Vicom, and I'd like to thank you for joining us today on another of our series of technology training webinars. This time on the OneAdvisor800, all-in-one tool for RF, coax and fiber testing. VIAVI Solutions and Vicom as a VIAVI Elite partner in Australia and New Zealand are working closely together to bring this webinar to you. Just a little housekeeping before we get started. This webinar is being recorded, and if you have any questions during the presentation, please type them into the chat box and we'll endeavour to answer them at the end of the webinar or shortly after. And now I would like to introduce you to our presenter, Celio Terame, who is a Regional Product Line Manager, APAC, from VIAVI Solutions in Japan. Celio is an experienced test and measurement engineer who has been with VIAVI for over 13 years. Celio has been working closely with the mobile and telecom carriers in Japan with special focus on the NTT group and fiber manufacturers and has a wealth of knowledge. Over to you, Celio.
Thank you, Avit. Hello, everyone. Nice to meet you. My name is Celio, as per the introduction by Avit. I'm in charge of the RF and Metro product lines of VIAVI across the APAC region and focused mainly on the 5G ecosystems and so on. Today, I would like to introduce an exciting new product that is called OneAdvisor800 or ONA800. This is a special tool that it was made for becoming an all-in-one tool for RF, coax, and fiber testing. So let's give it an overview of this. Today's topics, I'm going to talk about the OneAdvisor overview. Then, because there should be some people here for cell-site installation as well as cell-site maintenance, I would like to talk about these two topics. And at the end, I'm going to talk about the unique feature of VIAVI products, not only OneAdvisor, but field testers from VIAVI in general, that has this feature of workflow automation that will make life easier for the technicians. Now, what is driving this business for having this OneAdvisor is the 5G. 5G is now, and we have some estimations and studies from different organizations that will have 1.9 billion of 5G subscription by 2024. And when you go to, for example, Ookla-speedtest.net, that you show the number of 5G cell sites, sites deployed worldwide, when we had around 7,000 sites by around beginning of 2020. And now by July of 2021, 1 month earlier than today, we had 26,000 deployments, which means that was pretty much 3.5 times of the deployments in the past. And we still see CAGR of 5G deployments going up. We are expecting to see less 5 LTE deployments worldwide, but in having more and more 5G deployments growing over the years. Now, what is driving this 5G use cases? This would be like something like remote surgeries, augmented reality, connected cars, farming, automated farming, as well as some of the broadband applications and industrial applications that will require many different types of connections. Now, the 5G evolution, how is this different from LTE times? LTE, which used to serve hundreds of megabits per second, can now support up to 10 gigabits per second in the RF. The core transport network that used to be 100 gig is now going to be upgraded to 400 gig. And I think the most difficult part on this network deployment today is the front haul that has been upgraded from the CPRI, which is a sync time of protocol, to eCPRI, which is Ethernet-based CPRI. It would be CPRI on Ethernet, which is a packet-based network. And because of the front haul differences require many types of synchronization, we have a one-way delay of less than 1 millisecond in 5G timing. That would require 400 nanosecond sync accuracy for real-time applications such as remote surgery, remote driving, automated driving, and so on. Right. So this is a brief overview of the network. I would like to talk about these three applications. Some people may already know this, but this would be enhanced mobile broadband, which would require a lot more bandwidth capacity for high-speed data traffic. Ultra reliable low latency communication, which will be the small latency type of communication for driving and automating cars and surgeries and so on. This is more for real-time applications. And massive machine type communication would be more for IoT applications, like having a lot of sensors in the machines that would require hundreds, thousands of connections simultaneously. Small traffic, but a lot of connections. And what is driving this business? We have a lot of different types of communications. Applications would require different types of latency, mobility, the traffic capacity. For example, mobile broadband would require a lot of traffic capacity, but would require less latency requirements because it doesn't really need, it needs more speed than the latency measurement requirements. Ultra reliable low latency communication would require a lot more latency and a lot of mobility that for beam serving, RF beam serving customers every time, but less and less traffic, broadband traffic. Whereas MMTC, machine type communication, would require a lot more connection density. And this is also shown in the graph in the right side. But it would require less speed and would not require so many latency, stringent latencies. And so these types of applications is actually what is driving 5G businesses to grow up, and more and more applications and cell sites to be deployed, including private 5G applications that would be sometimes used for electrical companies, mining companies, and as well for serving private areas of 5G, whereas it used to be for private LTE. Now for the RF part of the characteristics, we have some millimeter wave, which is a new concept that is being used for 5G. People used to use this sub-6 band, which is referred to as FR1 in the past, that is lower than 6 gigahertz. Now this millimeter wave, which is something around above 25 gigahertz, and some people are mainly using this 28 gigahertz band at the moment, and also having some studies for utilizing 38 gigahertz or even 40 to 44 or so on. Because of the higher frequencies, the directivity and the path loss is going to be much higher at these new higher frequencies. So FR1, whereas low frequency cells, like people used to refer to this band as platinum band, like in iPhone and other major carriers using these frequencies, that they used to go up to tens of kilometers. Now in mid band, which is required to around 3 to 4 or even 6 gigahertz, the coverage area now goes a little bit smaller. Now for above 26 gigahertz, this could be in the sense of tens of meters, even 100 meters, 200 meters, less than 1 kilometer for sure. And this is actually something that is driving a lot of testing requirements for all of these types of networks. So LTE and 5G in the lower frequencies, they're going to remain as DSS probably, which uses LTE and 5G in the same frequency that LTE used to be used. Some new frequencies allocated for 3 gigahertz and above for 5G only signals. This could be another new type of application. And now millimeter wave native cell sites that would have antenna built in, same into the RU. So ONA800 now brings a lot more flexibility for field technicians for installations and also maintenance testing. So we have a slogan that says one solution, one process, one report. And I'm going to go through this in more details over the course. So OneAdvisor is a test tool that has been designed for having versatile concept and modular scalability to serve as a fiber cable verification, fiber inspection, optical power measurement, fiber verification like in OTDRs or spectrum analyzers. It also can support coax cable verification, coax. That this would be the normal return loss, VSWR, cable loss, and distant DTF insertion loss testing that needs to be done through the RU, between the RU and the antennas when you have a coax cable. After the connection is done, the cell site is done, you also need to do a lot more testing on the field, like LTE signal analysis, 5G signal analysis, X-hole. This would be something a little bit more different in the fiber side. You also need to test RF over fiber because some connections, they do not have the way for getting the spectrum from the field. So this is a way for recovering the spectrum shape from the fiber side. You also need some RF spectrum analysis tools and for maintaining the cell sites and fighting interferences. So what we have came up together is this OneAdvisor or ONA800 that would have all-in-one capability for testing all these features in one. This is the first in market concept that we have brought up since last year, and we are the game, I think, runners ahead of competition and bringing this one type of solution. Now, OneAdvisor800, it brings your scalable test solution, as mentioned before. So it would be a 8-inch touch panel tester that would be used for having pluggable modules at the end or in the middle. So we have two types of modules. That is full width module that you're going to put at the back. This would be the radio analysis module. This is the RF analysis module that we put in the back. It can also have more modules, which would be the half width modules that could be OTDRs, WDM channel checkers, optical spectrum analyzer modules. This would be for the fiber side of the verification. You can also plug coaxial cable test cable and antenna analyzer module for testing the coax cable at the back. So you could have capability for have mixture of fiber inspection probes via USB connection, coax test, and also radio analysis test. And we have some of the radio analysis test options that on the right-hand side. Now, you would have lots of configurations and limited types of configurations. So we have came up with 3 types of packages that would serve initially key basic types of customers. Now, ONA800, the first package would be for the contractor market that would serve for the telco and mobile operators or even the mining when you have a cell site to turn on. So you're going to have the cable and antenna analyzer test and fiber inspection tests like OTDRs and fiber scope. And this would be how it looks like. So you would have the tester plugged with the cable antenna analyzer module and the fiber module here at the back. Now, for the second group for the users, that would be the maintenance team, would require a lot more RF analysis capabilities like spectrum analysis, interference finding features, real-time spectrum analysis, RF over Cypri, which is a way to recover RF spectrum from the fiber, and some of the other antenna signal analysis depending on the technology you're running. In this case, you don't need the cable antenna analyzer module and even the fiber module, but you're going to have an RF analysis module, which is the full width module. And this is how this is going to look like. Now you have the third group of maintenance, advanced maintenance team that would require all of the above, including RF analysis, including cable antenna analyzer tests for some bad VSWR links or some fiber break suspected links, for example. In this case, you would have all in one. So bundled with the RF module, the cable antenna analyzer module, and fiber module. So this would be the all-in-one test tool that you're going to store at the back of your car so that it can do anything that is needed from the installation up to the maintenance and troubleshooting. VIAVI now offers a complete portfolio for RF cell site installations and maintenance. Depending on the technology, one key difference would be his older brother, that would be the CellAdvisor 5G, which support frequencies up to 44 gigahertz. And the main differences between CellAdvisor 5G and OneAdvisor800 would be the frequency range. So CellAdvisor up to 44 gigahertz when millimeter wave analysis is required. OneAdvisor800, it goes only up to 6 gigahertz, but has all of the features that is required for normal maintenance and troubleshooting and installation. Okay. So today, this is going to be the product we're going to talk about. And one thing I would like to emphasize before we go on more details on the features is remote access via cloud. This is a common feature across many of our portfolio, our platforms, including CellAdvisor, including OneAdvisor800, and also some other products like MTS5800, which is a bit error rate tester for Ethernet, SDH, OTN, CPRI, and others. And portable OTDRs like MTS2000, smart OTDRs, and others. So what is unique in this feature, and some people here may already be using this feature, whenever you have you need a need for controlling the test from your office side or from your home. If you don't have an internet connection, then this is going to be difficult. But normally when you are in the same office or so, in the same network, it is easy to get access to this remote testers. But if you are on the field and you don't have intranet connectivity between the office and the field, you have an easy way for having some kind of a Wi-Fi tethering, either using your cell phone or a mobile router, for example, or even a Wi-Fi hotspot that you may have in the cell site. And from the internet connection, we have a server that will be providing you a one-time password that the technician on the field can communicate to the technician in the office. The technician in the office is going to type in the password code and start getting control of the unit. So whenever you are touching the equipment at your side, you're getting the real-time screen analysis at the PC side or in tablet. Whenever you touch on and try to manipulate the tester, this is going to be reflected on the field as well. And this is also useful in COVID because some people has some limitations for getting to the work environment or going to the field. So somebody that can just bring the tester at the site in emergency cases and have the connections, and then somebody at the head office who is an experienced technician could get the control and start doing all of the measurements. This could be also done by transferring data real time. Like after you finished all of the test measurements, you create a report, and via FTP connection, your PC or smartphone, you can just download the tests or even upload tests so that you can do this. So this is a common feature for all of the platforms that we can serve on the field. And based on this, I would like to start introducing you some of the installation and maintenance tools, features that we have. So for cell site installation, What would be important for this cell site installation would have some fiber cables and coaxial cables tested, verified one time, and make sure that all of your tests has been done correctly, properly at the first time, right? So, and we have some features that would help not other than the fiber inspection, optical measurements, OTDRs, return loss, VSWR, cable loss. These types of testing would be something common already. So a normal technician would bring an OTDR to the field, as well as a cable antenna analyzer to the field. So it would require 2 test equipment and try to get people getting 2 types of test results uploaded somewhere in the cloud. Now, OneAdvisor800, it has a feature for having StrataSync, which is VIAVI's cloud-based platform that is used for uploading and downloading data, like uploading test results, downloading test setup parameters. It has a feature called Job Manager, which is a built-in guidance, and that is going to automate your workflow for getting constantly concise test process according to MOPS, and get pass-fail analysis and consolidate multiple tests into one test result so that you can upload to the cloud later. And also you have the Smart Access Anywhere, which was the feature I presented before, to help troubleshooting for remote access and instantaneously for in case you need some help on the field. Now, OneAdvisor brings you the feature for having the same box, one box, for having coax and fiber all together. Okay, so in X hall, in this case would be the front hall. When you have a macro cell site installation, you would probably have the fiber up to the bottom of the tower in a connection box or in WDM or box or anything. So this would be the fiber. And you would also have the fiber up to the tower where you have the RU or the RRH in LTE. And you also have the last portion of the coax cable from the RU or RRH up to the antenna. Now you need some features to test the feed line the coax feed line for return loss and DTF and cable loss here, which would be supplied in this OneAdvisor coax module. The fiber X hall that would require a fiber inspection tool for connector end face cleanliness verification, OTDR for dark fiber testing, or even WDM channel verification if the back haul, the front haul here is done by a WDM transmission. And the workflow automation on this OneAdvisor is also going to help you through going through the CAA cable antenna analysis and also the fiber verification in a method that it will guide you. So you need to do, for example, sorry for the bad resolution of the image, but in here, this is going to guide you through fiber inspection, through OTDR testing, to cable antenna analysis, CAA Check. This is a new unique feature that, this is going to guide you one by one. What you need to do on the field, what are the test parameters you need to set. These will be all loaded here, and the technician will be able to then launch the fiber inspection application or launch the OTDR application, which is in the middle here. You would run the OTDR test, would save the OTDR test, and then you go to the CAA check where cable antenna analysis and that you're going to go have for the coax part. This is going to guide you through the coax testing. After you finish all the coax and you finish all of the tests that are in the job manager, this is going to create you a simplified report so that you can upload to the cloud and your manager can go and see the test results real time. So this would be the workflow that we are trying to pitch. And we have been successful in some of the markets that need coax and fiber and all in one together. So this would be a normal test process for the macro cell installation. Now, in case of small cell installations where you don't have a coax feed, but you have a built-in RU, or this is more for the 5G new installations, that you have an RU with integrated antenna, built-in antenna. You don't have a feeder for coax outside. So everything from the back hall up to the front hall and RU, everything here is fiber only without any coax part. So this RU will have built-in antennas that will be transmitting sub-6 or millimeter wave signals in the RF. In this case, you don't need the coax, but you need the fiber testing tool. That will be the same thing, like fiber end phase inspection for cleanliness of the connector, fiber validation using OTDR to verify that there is no link breaks on the link. You need to verify the return loss and insertion loss of each parameter, each event along the fiber. Or again, if you have any WDM testing, you could use a channel checker for WDM, or even an optical spectrum analyzer module that could be plugged on the back. Okay, so this can also be guided through the same management workflow job manager. In this case, I'm going to have one more example where you need to have a fiber connector inspection at every site, like in the RU SFPs or the cables that you're connecting to the RU, to the connectors in the WDM on the patch panel and the cable of the DWDM network, right? So, and also do some of the OTDR or WDM channel checking, testing. And all of this job can be programmed according to the manager's wish. So we can also help in creating these types of profiles, and for the job manager, our engineering team is always available for testing, for supporting the field technicians. So this can be done easily, deployed easily, and performed easily. So a good benefit for this would be that the test parameters and test sequences and all set up, this can be done by the manager without the technician taking time on the field and in doing setups and stuff. Now, one thing that I would like to emphasize again is when you're doing a cable antenna analysis testing, for example, in this first example, you have different types of return testing, like return loss, DTF, insertion loss, and normally you would have many types of bandwidth to test at the same time on the cell site. In case of a shared tower, for example, that you need to test for 2-3 carriers, operators using many types of different frequencies, and a smart pole, smart antenna, it would require a lot more testing and setup. What we have came up together to bundle together with this job manager is a feature to try to have cable and antenna analysis itself automated inside the automation. So, or if you have only cable and antenna analysis check, you don't even need to use the job manager, but you can go through a new feature that we have came up. This is the cable and antenna analyzer check, which is the automated workflow only for CAA tests. So the benefit of this is that the technician, when you go to the field, it can only come and load a profile and start testing right away. Or if you are the manager making the profiles, you can come here and start making the tests on the site, make the sites. And after you save the file, the profile, this can be used as an automated routine for repetitive tests. So you can broadcast your profile file to everybody on the field. Everybody can import the same profile and start using the same parameters so that it can have unique and concise, reliable test measurements to have the same results done by any technician. So what is the process? Process would be to create and save the profile, run the profile, switch between the test and live measurement if you need some troubleshooting, save the measurements and create a report. So I'm going to guide you through briefly this process. The CAA check. This is how the screen looks like. So you can go through a VSWR connection testing, DTF testing, cable loss testing as normal way, one by one, as in other testers or our previous testers, and do the testing, create reports for every test parameter. You can take the data, you can go back to Office, start creating a consolidated report in a PC application, but you don't need to do that anymore because CAA Check is here. It is going to automate all of the tests for you. So now you're going to select the CAA Check, you press done. You can load or create profiles. So I will start first with creating profiles. So you will have many types of profiles that was loaded in the beginning before the test is done. And you'll have some of the test parameters. What are the tests that are going to be done inside this sample CAA file, for example, and you load it. Or if you want to create a new profile, if you're the manager, you want to create a profile, you can also get many types of testing here. You can put at the bottom on the beginning, you can load for feed A to feed B, right? And you can set parameters and set actions like if you want to do a calibration every time before a test, or if you're only prompting for a calibration whenever this is required because the calibration is out of validity. You can select the peaks, you can select the thresholds, and you can also, all of these tests are going to be consolidated into one PDF report at the end. But you have the ability to select whether you want to keep individual test results in the background for storage, like a trace or a screen-only image file or a CSV file. And you can select all of them if you want. So once you finish all of the measurement, it is automatically going to keep you the test results in the background. And at the end, it is going to get you a PDF report of all of the tests. Now, after setting and creating the profile or loading the profile, now you can go and run the test. So you have a start button at the beginning, and it is going to go through all of the measurements. And depending on the type of measurement, the system is going to prompt you for example, using the Y calibration kit and connecting open, connecting load, connecting short. So, and visually, so that you don't have the need for going and analyzing by yourself and deciding by yourself which are the connectors you need to connect, because the system is going to guide you through. Now, once you have all of the measurement going on, you can also verify the test results of past data. If you have a completed test, you can go and verify what was the output. If you have a test in progress, you can also verify and see the real-time traces. You can come back, and after all of the tests are completed, so for example, if you set a threshold, it is going to set you pass or fail. If you don't set a threshold, it is only going to show you complete or incomplete. Now, after everything is done, you can go to report, or you can even restart if you want. But in the reports, you're going to be putting your name, the cell site location, anything else. You can also attach some pictures and make the logos for your file and create the report. This is automatically going to generate you the PDF report for all of the measurements that you have done in this profile. So some screenshots, samples, like having the overall summary, having the return loss test result with the fail, with say DTF, with the pass, right? If you don't set the thresholds, you will not have the pass-fail analysis, but you only have the traces. And as said before, you can keep the traces information. It will keep you the storage, the test individual traces, if you have selected in the beginning in the checkbox. So this is a way for automating all of the tests and having concise test process all over the field technician team. So everybody doing the same. If you have a same carrier profile to test for Telstra, for Vodafone, for anybody else, so if you have a certain frequency to test and you have a method, MOP, for doing that, you can just put all of these MOP test parameters inside, and you can run this via easy test process, automated. So up to here is what we use normally pitch for the cable and installation, cell site installation market. And from here on, I'm going to talk a little bit more in details about how technicians can be maintaining the cell sites after the installation has been done. So OneAdvisor, not only for installation, it can also be used for maintenance purposes. And differently than the installation teams, these would be more of the types of testing that the cell site maintenance teams would require, like real-time spectrum analysis with gated sweep, OTA signal analysis, and depending on the cell site, it could be LTE, it could be 5G, it could be DSS, which stands for dynamic spectrum sharing, that is LTE signal mixed up with 5G together in the same frequency band. So interleaving between LTE and 5G in the same frequency band. NSA, that stands for non-standalone mode, which would require an anchor LTE for control plane transmission, and 5G signals in a different carrier for user plane and others sync data. Interference analysis, that would use for hunting illegal interferences or some problems on the field. EMF analysis, electromagnetic field analysis for compliance verifications and health verification as well. And also X-Hall verification would be coax and fiber. This would be the same. This could be used or could not be used, but I'm going to focus a little bit more on the RF analysis. And the same way we were doing for the installation that can automate the field technician's process with fiber and coax, we can do the same with all of these features combined with what the installation team can do. So in here, you can also use again the job manager feature to automate all of the tests, StrataSync for uploading the tests, and Smart Access Anywhere again for troubleshooting from home. If somebody, for example, we have some use cases in Japan that people take the OneAdvisor at the car, they start driving, and somebody from home, because people are in lockdown situation, from home, people can help the drivers to validate this interference hunting. Now for 5G cell site deployment, so these would be some of the test processes that are normally required. And this would be carrier profile that would be verify the center frequency of the bandwidth along like 100 megahertz or 80 megahertz of the bandwidth allocated using a real-time spectrum. You would also validate the beam, which would be basically verifying the SSB with the sync signal block and try to get here. In 5G, the sync signal block could be in the middle of the spectrum, or could be at the right side, left side, or right side by sync raster, and it can be moving depending on the carrier setup. So it would be important for the technician to find out the SSB in the spectrum to verify the spectrum health. Now, aggregation. When you have multiple carriers that would be aggregated, it could be for LTE as well. If you have channel aggregation, carrier aggregation, you could measure up to 8 cc in this with OneAdvisor. And beamforming analysis, this is a new concept for 5G that you would not only have the PCI, the physical cell index, but inside the same PCI, you would have different types of multiple beams injected. So for lower band, you could have up to 4 beams. For mid band, which would be up to 6 gigahertz, you would have about 8 beams. For millimeter wave application, you could have up to 64 beams in the same PCI. So this OneAdvisor would have the ability to validate, to identify individual PCIs and beam numbers. And also based on these beam numbers and validation, you can also do some route mapping for plotting the test data on the Google Maps map. Now, the real-time spectrum analysis, this is something different than the normal gated sweep type spectrum. And this is very useful for getting test results and finding interferences and analyzing signals in TDD signals that uses the same frequency for uplink and downlink, same together. This would be an example of how the signal, the same signal, this is an LTE, by the way, how this is different between the sweep spectrum on the left-hand side to real-time spectrum at the right-hand side. So normally you would have to put this in max hold mode so that it will wait you a little, you would wait for a few seconds for getting the max shape of the signal. But when you do that, you're actually missing some of the spectrum at the bottom, which whereas in real-time spectrum analysis, which would have the real-time snapshot of the entire 80 megahertz, 100 megahertz, up to 100 megahertz snapshot, you could find interferences, for example, like in here with persistent spectrum, easily finding in-band interferences. Now, not only for real-time spectrum analysis, we also have some methods for analyzing downlink and uplink with gated sweep. We have a method for getting downlink, uplink, and we have a dual gated window that you could set for uplink locations depending on the technology, on the frame format, and try to have this time domain application on the right upper side, analyzing the downlink lower end side. You could have analyze spectrums in special gated windows like in the uplinks, so that you can find out specific interferences that are happening in the interference in the uplink timing. This would be more difficult to find out because the downlink itself would be making it difficult to analyze these kind of interferences in the uplink. So by having this gated sweep to focus only on the uplink and try and recovering frequency from there, this would be something very useful for finding interferences. Now, another key nice feature for finding interferences would be RF over CPRI. This is a way for retrieving the spectrum that comes from OTA from a fiber link. So from the BBU, RH, from the link between RH and BBU, you would need to have a splitter or a tap that would, for example, divide into 90% and 10% and get 10% from the link to an SFP port of the ONA, OneAdvisor, or 1% of the link. And from here, you can actually retrieve the IQ data from the payload and try to get the spectrum shape from the fiber side. So in this section, you're getting RX1 to 4, and this would be very useful for analyzing PIM. So when you have an interference issue, you could try to go and differentiate between outside interference or inside interference would be the PIM, passive intermodulation. And this would be a powerful tool that you can go and analyze the PIN and based on from the RF fiber side. And this is actually very useful because once the service is on, linked up, or you're not able to get some of the, like an integrated RUs that would have the antenna built in, there is no way for getting the spectrum from the field side, unless you're doing RF over CPRI analysis. So this would be a very powerful tool that we would be very happy in showing to people. Another way for finding interferences would be having an interference analyzer. This is a special tablet tablet application that we have, that when driving and you know that there is a suspected area, but you don't know exactly where the location is. So you have an Omni antenna attached to the top of your car. You have this tablet. You download the Google Maps links, and you set the parameters on the OneAdvisor and start driving. You just keep driving, and the tablet is going to guide you via voice. So you go right, you go left, you go straight, right? And you're going to, after driving some time, you're going to have roughly a suspected area which you would have some interference analysis issues. After you find roughly the location, you now get out of the car, and now you come with a directional antenna with a special handle that we serve together, and you start doing triangulations. So like in radar chart, you go 360 degrees to try to find from which direction the interference is coming. And you start doing this in many locations, so to the triangulation and try to find the exact location. And this could be very useful for finding like illegal repeaters, faulty repeaters, or even equipment purchased from overseas and imported from overseas that would have non-regulated, non-compliant regulations on the country that would be emitting illegal signals. Now, after this, for in-depth signal analysis, we would have some methods for doing LTE signal analysis. This would be something that is pretty much old. Most of the people would know already how to do this. The same way we do with LTE, we can also do with 5G. So for 5G, we have basically a few modes. I'm going to show only 3 modes. That would be the 5G carrier scanner. The user would put different types of carriers, and the tester is going to scan through the carriers and find how many channels you find, which are the coverage that you're finding in that particular spot. Or the beam availability. So for that specific location, you set the PCI, for example, for 78, and you're going to test whether you have the 8 beams available at that part, where you can focus only on one beam. Like in this example, you are in beam number 0, which is the first beam, and retrieving constellation information from this side. Or even from this, if you want to get a route map to verify the city coverage, for example, you can download a map from the Google Maps or Google Earth, and you can start doing the driving, and the unit is automatically going to plot your signals based on the GPS coordinates from a GPS antenna that you plug on top of the equipment. This would be something that's very good for verifying coverage and finding coverage gaps. If you have DSS, again, this is dynamic spectrum sharing, that you would have the same frequency being used by LTE. The LTE carrier would normally try to use this DSS to try to expand 5G NR coverage, and they would be interleaving to each other, having LTE and 5G NR in the same frequency. So the OneAdvisor has the ability to differentiate between LTE and 5G NR and do the proper analysis the same way we were doing with LTE or 5G analysis individually. It can go and combine both together and try to get constellations, doing more analysis, and also doing some of the mapping based on 5G or LTE signal at the same time. Another way that is pretty similar but not a little bit different would be the NSA, the non-standalone mode, that would have LTE anchor carrier together with the 5G NR. So in this case, we can set up to 8 carriers in the same screen. In this screen, I'm showing only 4, but you can also split in half so that you can have 8 carriers analysis at the same time. And this would be the same analysis that you're doing with LTE. So like in NSA case, we would have 1 5G and 2 LTE anchors, or you could have used the same one for analyzing 3 5G carriers and 5 LTE anchors, for example. And if you want to do some mapping on the field, you can select up to 3 carriers among these 8 that you're analyzing and do this mapping the same way we were doing with DSS, LTE, or 5G. Now, if you are in a location that you don't know what type of signal you're transmitting, you have a new feature that is called blind scan. You can just set up the frequency range that you want to search, and the unit is automatically going to get you what are these signals. For example, if you are getting some 3 unknown carriers in real-time spectrum analysis and you want to know what are these carriers, and then you can just run this blind scan. This is going to automatically identify you that this is 5GNR, 5GNR, or even LTE. And if you select the special carrier that you have searched and you click on this icon, if this is a 5G analysis mode, you can go to a 5G beam analysis mode. Or if this is a 5 LTE, you can go to LTE analysis mode and you can start doing all of the tests the same way we were doing before. Now we have some EMF analysis tools as well. I'm going to go very short on this, but in short, we have 2 methods of doing this, which is frequency selective, that is code insensitive. So this would be a frequency type of EMF analysis that you're going to set the bands or multiple bands for accumulated testing, and you can set from 1 to up to 60 minutes so that you can collect data during 60 minutes for getting max, minimum, average for each of the frequencies accumulated. And because this frequency selective method is more suitable for FDD transmissions where you don't use uplink and downlink in the same frequencies. For 5G NR beam analysis and EMF analysis on 5G, you would have to be code selective. So the OneAdvisor has the ability to decode depending on the PCI and the beam, and it has a special extrapolation formula that you're going to get very accurate test results by extrapolating EMF power based on PCI and values, PCI and beam index values for this. We can go through this EMF analysis in more details if anybody wants, but this is going to be a very dense topic, and we would like to be happy in presenting as well. I think I'm a little bit short on time, but I'm going to go through some of the workflow automation process that we have. Now we have presented a lot of these workflow and test parameters that can be done on the field. And as mentioned in the beginning, we have some features called Job Manager. But some of the challenges on the field that we have been observing before coming to this Job Manager features was that there is a lot of manual configuration and inconsistent testing happening on the field. And people spend a lot of time in doing setups and doing the measurements. It can get wrong measurements, and it would, for example, getting inconsistent test results, missing or invalid data, and delayed report that would result in repeated truck rolls that you need to go back to the cell site again and do the testing and resend the test reports. And we have this is a global issue that we are having, that we're having less and less people available in the market. So people need more time for training. And some experienced technicians could be very busy at that moment and could not have the time for doing all the tests, especially with COVID lockdowns. You need to do shifting of the timing between the technicians. So this is very difficult to manage the time testing, on-time testing, first-time test, correct? So you'd have a lot more OPEX being spent caused by people spending a lot of time on the field or going back to the same location at the same time for repeated truck rolls. and that would result in customer churn for unhappy customers. So what we have came up with is this StrataSync workflow automation. This is the same thing that we do with the job manager, but having the test pro tool available. All of this is done using StrataSync, which is our cloud platform. So on the cloud, you're going to set the proper instrument with the serial numbers and stuff. The instrument will have the firmware version, the configuration, all of the software option deployed, and asset manager that would assign the proper job and the field tester to a specific person. So you're going to create all of the jobs, like the right technician, who is going to do the test, what are the test limits, like the thresholds, what are the label names and report names, and then what will be the job manager, process manager, the process, and everything is done by the manager. Now you're going to deploy the field tech, the test that you have set here using the mobile tech app. The field technician is going to get a notification on the mobile app, and this is going to guide you to which tester you need to take on the field, what are the test parameters you need to load on the field. And this is all done via cloud automatically. If you just sync up your tester with the StrataSync, this is going to get all of the tests. And again, like one button, one check test would be something that we provide, same thing like in the CAA Check feature. We are very committed to try to get to the field and to the market some features that would be prompted by this, the tester itself. And that would require less and less button presses so that all of the field jobs could be automated. Now, after all of the test is done, you would have all this data automatically uploaded to the cloud. And your manager will be able to get the test reports real time and try to get all of these dashboards so that you could have the tests done properly at the first time, and the manager would be verifying prior to this technician going back home and leaving the job environment. Right? So with this TPA, which is abbreviation for test process automation that we call in VIAVI, this would be bringing a lot more benefits to the field rather than comparing to normal ordinary people, field testers that you used to use in the past, and especially for having 90% more time saved due to technicians spending time in setting up the field test instruments on the field, and 24% time saved due to repeat works, repeated truck rolls that you need to go to the field again to do the same job. So to have the jobs done right at the first time. So this would be something that we'll be bringing together with the TPA, test process automation, via StrataSync and all OneAdvisor. So OneAdvisor, again, as a summary, this is the only one tool in the market that can test RF, coax, and fiber. Only one together with some of the job manager and cloud automated test workflow automation. So this would be one solution, one process, and one report that could be serving for the entire RF, coax, and fiber networks. And VIAVI provides not only this RF and fiber, but we, some of the people in this webinar could already know already, but we have some fiber specific tools for fiber installations like fiber inspection, OTDRs, transport testing for C3 front haul latency, and the OneAdvisor that we have showed together today, together with StrataSync. Okay, with this, I would like to finish my presentation. Sorry, I think I'm a few minutes late for the Q&A. Probably I left no time for Q&A. My apologies for this.
Thank you very much, Celia. That was a very informative presentation. Especially, I thought the overview of the challenges of field test operations, RF interference analysis, and automating cable antenna checks to be very enlightening. That brings us to the end of today's webinar, everyone. please email us with your feedback on how we did and whether we met your expectations. We'd also like to hear from you about any other topics you would like us to cover in the future. As I mentioned in the beginning, this webinar has been recorded. Our link to this recording of this session will be available within a day or two. So if there's anybody in your organisation that has missed out and would like the link, please let us know. And of course, if you have any further questions, or perhaps you would like to discuss Vicom and VIAVI cell site installation or maintenance test solutions, please contact Raj or Philip. You have their contact details on the bottom of your invitation. Thanks again for joining us today, and we'll see you next time. Bye for now.
Find out more at Vicom's website.